Hello everyone. Today we'll look into outliers. What are outliers and how do we identify them? Today we'll look into two methods. One is the IQR or interquartile range method and the other one would be the standard deviation method. So what are outliers? Outliers are basically observations that are unlike other observations. It is rare, distinct or does not fit to in some way. Those can also be called as anomalies. So what causes us to have outliers? Measurement or input error. Maybe the experiments that we conduct for getting the data have an error in it, are erroneous, or while collecting the data we make an error, so that is called a measurement error or input error. You can have data corruption or it might be true outlier observations. So over here in this picture we can see there's a giant and there are normal sized people. So over here the giant is an outlier and these are normal data. But we will see how do we identify the giant, like how big would be an outlier, like till what height of the person, till what height will I call it to be a giant. That is what we will look into. Now what are types of outliers? There are univariate and multivariate. Univariate outliers can be found when we are looking into a distribution of a single variable. Multivariate outliers are outliers in an n-dimensional space. In order to find them, we have to look into the distribution in a multiple dimensions. Right? So what impact can an outlier have on the outlier and dataset have on our results? It can increase the error variance and reduce the power of statistical tests. The outliers, if the outliers are non-randomly distributed, they can decrease the normality. If they have a pattern to it, if the outliers have a pattern to it, they will change the normality. They'll decrease the normality. I mean, so they can bias or influence the estimates that may be of substantial interest. They can also impact the basic assumptions of ANOVA and other hypothesis testing or even of regression. So basically, like for a regression, the primary assumption is the data is normally distributed. If there are outliers, the normality is affected and hence the basic assumption is affected. So these can have basically, so outliers can have basically drastic effects on our results or on our analysis. So we'll look into how to identify the outliers. So identifying them is very essential, otherwise it will affect our results. So we'll get into the identifying part. So for this we'll look into the heart diseases data set. We have age, sex, the BPS, cholesterol, so on and so forth, and a few of the variables. There are we'll consider the cholesterol for our analysis. We look into the box plot now. We have the box plot. So any point which is more than the upper whisker, these are whiskers, these two are whiskers, any point more than the upper whisker are basically outliers. Similarly, any point below the lower whisker would be considered as outliers. So we'll look into how to define these whiskers. So the first method that we'll look into would be the interquartile range. So basically, what is IQR or interquartile range? It is the difference between the third and the first quartile. Is Q3 minus Q1. The upper whisker that we saw would be defined as Q3 third quartile plus 1.5 times the IQR, whereas the lower whisker will be defined as Q1 minus 1.5 times the IQR. So this is how we define the upper and the lower whisker, where IQR being Q3 minus Q1. So let us look into how we can do it programmatically. So basically we define what the IQR is. We define the cutoff, that is IQR into 1.5, and then say upper is basically third plus first minus the cutoff, and there's a lower, and the upper is basically third plus the cutoff. Now let us see how many outliers does our data set have. So basically we have 5 outliers. Upper bound is 69.75, lower bound is 115.75, and the IQR is 63.5. So according to the IQR method, there are 5 outliers. Now we look into the So okay, looking to the visual representation. So over here, any point which is in red are outliers, and the blue are the normal data points. So any point falling in those red zones are outliers. We have a few points over here that is falling into the red zone, which is adding to our 5 outliers. So how can we remedy this? That is, we can remove the outliers. Basically, by removing the outliers which is lower than the lower quartile and the upper. We are basically keeping the points which are between the upper and the lower quartile, that is within the valid range. So we have a few points outside the upper whisker and a few points lower than the upper whisker, lower than the lower whisker. The next method is the standard deviation method. So for a standard deviation method, we consider it's a normal distribution. So in a normal distribution, basically 68% of the data points lie within the first standard deviation, 95% lie within the second standard deviation, and 99.7% lie within the third standard deviation. So we'll use this particular principle for identifying outliers. So for this we'll use the student's performance data set. How would we do that? So basically, we'll first plot the writing score. So writing score would be the basically the variable on which we'll identify the outliers. So on plotting the writing score, we see that the writing score is skewed, which means it is not a normal distribution, pure normal distribution. It is skewed, which means it has got outliers. So we have to identify them. How to find them? So what we do is basically any point which is beyond the third standard deviation will be considered to be an outlier. So according to this analysis, there are 4 outliers using the standard deviation method. What did we do? We basically set the cutoff being basically standard deviation into 3, that is the third standard deviation. So any point which is lesser than the mean minus the cutoff, or any data point which is beyond data mean plus the cutoff, is a outlier beyond the upper or the lower point. Let us plot the data. So over here again, any point which is beyond the upper limit is any point in red is basically the outliers. So what are the remedial methods? Again the same thing, we keep the data points which are within the upper and the lower limits. So that is how we do it. So this is our analysis for today, or the exercise for today. The next day we'll look into other methods for multivariate analysis like DB scan, so on and so forth. And this notebook contains all the methods for univariate and multivariate. Univariate also contains a few other methods like z-score method, which is basically an extension of the standard deviation method. So I'm not getting into that, but the process of doing it and the code for it will be there in the notebook, and I'll attach the link of the notebook in the description box. Thank you and hope you like it.